For centuries, Saturn has captivated human imagination. Through telescopes, it appeared as a distant jewel surrounded by magnificent rings, a world unlike any other in our solar system. When the Cassini spacecraft arrived at Saturn in 2004, it began one of the most ambitious planetary exploration missions ever attempted. Over the next 13 years, Cassini transformed our understanding of the ringed giant, revealing breathtaking landscapes, violent storms, hidden oceans, and moons that may hold the ingredients necessary for life. By 2017, however, the mission was coming to an end. Scientists faced a difficult decision. Cassini was running low on fuel, and mission planners wanted to ensure that it would never accidentally crash into one of Saturn's potentially habitable moons. To protect these worlds from contamination, they directed the spacecraft toward Saturn itself. On September 15, 2017, Cassini made its final descent into the planet's atmosphere. As it plunged deeper into the clouds, the spacecraft continued transmitting information back to Earth until the very last moment. Then, after years of faithful service, the signal disappeared forever. At the time, many believed the story was complete. The spacecraft had delivered hundreds of thousands of images and an enormous collection of scientific measurements. Researchers around the world spent years studying the information. Discoveries were published, theories were refined, and Cassini secured its place among the most successful missions in space exploration history. Yet science has a habit of revisiting old mysteries. As technology advances, data that once seemed ordinary can reveal entirely new insights. Information collected decades ago is often re-examined using modern tools that did not exist when the data was first gathered. What was invisible yesterday may become obvious tomorrow. Several years after Cassini's mission ended, a group of researchers decided to revisit portions of the spacecraft's final image archive. Their goal was simple. They wanted to test advanced image processing systems capable of identifying subtle structures hidden within noisy visual data. The technology was remarkable. Unlike traditional software, these systems could compare vast numbers of images simultaneously, searching for relationships that human analysts might overlook. Tiny variations in brightness, shape, and alignment could be examined across thousands of frames in a matter of minutes. At first, the project appeared routine. The software enhanced image quality, reduced visual noise, and highlighted atmospheric details previously difficult to observe. Researchers expected to gain a slightly clearer view of Saturn's cloud layers and perhaps uncover minor scientific details. Instead, they encountered something unexpected. Within a small collection of images captured during Cassini's final hours, the system identified repeating geometric structures. The shapes were faint and difficult to recognize. They appeared only after extensive processing and enhancement. Initially, the research team dismissed the findings. Space imagery often contains artifacts caused by camera sensors, compression techniques, lighting conditions, or transmission errors. Strange patterns can emerge naturally when enormous quantities of data are processed. But the anomalies refused to disappear. The same structures appeared in multiple images taken at different times. Some emerged from entirely separate datasets collected during different stages of the spacecraft's descent. The consistency attracted attention. Researchers began asking questions. Why were these patterns recurring? Why did they appear in locations associated with unusual atmospheric activity? And why had nobody noticed them before? As investigations continued, additional details emerged. The structures appeared to possess a degree of symmetry uncommon in Saturn's turbulent cloud systems. They were not perfect geometric forms, but they displayed enough organization to spark debate among analysts. Some scientists argued that natural processes can produce surprisingly ordered patterns. Snowflakes, crystal formations, hurricanes, and planetary weather systems often generate complex geometry without any intelligent influence. Others believed the discovery warranted further study. After all, Saturn itself hosts one of the most famous geometric features in the solar system, a massive hexagonal storm surrounding its north pole. Nature is capable of remarkable organization, but understanding how such structures form remains an important scientific challenge. The mystery deepened when researchers compared the anomalies against atmospheric models. Certain patterns appeared near regions where Saturn's magnetic environment behaves differently than expected. These areas have long fascinated scientists because the planet's magnetic field displays characteristics unlike those observed elsewhere in the solar system. Was there a connection? No one knew. As discussion spread through scientific communities and online forums, speculation rapidly outpaced evidence. Some enthusiasts proposed extraordinary explanations. They suggested that the patterns might represent unknown technology, evidence of hidden intelligence, or signs of a phenomenon beyond current scientific understanding. More cautious voices urged restraint. Throughout history, people have often interpreted random information as meaningful patterns. Human brains are exceptionally skilled at finding order, even when none exists. Faces appear in clouds. Shapes emerge from shadows. Coincidences become mysteries. This tendency has a name: pattern recognition. It is one of humanity's greatest strengths, but it can also lead us astray. Determining whether a pattern is meaningful requires rigorous testing, independent verification, and extraordinary amounts of evidence. Nevertheless, the mystery continued to grow. As image archives were examined in greater detail, researchers discovered additional irregularities within the final sequence of data transmitted by Cassini. Most had straightforward technical explanations. Some were linked to transmission challenges experienced during the spacecraft's final descent. Others were attributed to environmental conditions and signal degradation. Yet a handful of questions remained unresolved. Among them was the challenge of reconstructing every detail from the spacecraft's last moments. As Cassini entered Saturn's atmosphere, conditions became increasingly extreme. Heat, pressure, and atmospheric turbulence affected the quality of the data reaching Earth. Those final transmissions represent the last surviving record of what the spacecraft experienced before it was destroyed. For scientists, that alone makes the archive priceless. Every byte of information offers a glimpse into an environment no human-made machine had ever explored so closely. What makes the story particularly fascinating is not the possibility of hidden messages or extraordinary discoveries. It is the realization that our understanding of the universe is always incomplete. Each generation inherits questions from the one before it. New instruments reveal details older technologies could not detect. Fresh perspectives challenge assumptions that once seemed unshakable. The history of astronomy is filled with examples. Planets once believed lifeless were found to possess active geology. Moons once considered frozen wastelands were discovered to hide oceans beneath their surfaces. Phenomena once dismissed as impossible became accepted scientific reality after better evidence emerged. Cassini itself was responsible for many such surprises. The mission revealed giant geysers erupting from the icy moon Enceladus. It mapped methane lakes on Titan. It observed storms larger than entire planets. Again and again, Saturn proved capable of challenging expectations. Perhaps that is why stories surrounding its mysteries continue to capture attention. They remind us that exploration is far from finished. Even today, scientists continue analyzing Cassini's vast archive. New studies are published every year. Researchers still uncover details that were overlooked during the mission itself. The spacecraft may be gone, but its legacy remains alive. Whether the unusual patterns found in its images ultimately prove significant or mundane, the investigation reflects the essence of science itself: curiosity, skepticism, and the willingness to revisit old ideas when new tools become available. In the end, the true mystery may not be hidden inside a single image or buried within a collection of data. The true mystery is how much remains unknown. Beyond Saturn's rings, beyond the distant planets, and beyond the edge of our current understanding lies a universe filled with unanswered questions. Every mission, every telescope, and every discovery brings us one step closer to understanding our place within it. And somewhere in that vast darkness, future explorers may uncover secrets that today exist only as possibilities. Cassini's final journey may have ended in Saturn's clouds, but its story is far from over. Because as long as humanity continues searching the stars, every ending has the potential to become a new beginning.